This is again, I'm a singer, eternal voice. So we are here to to present you another example for the chemical reaction kinetics. I have here, oh my god, question number 2 because yesterday I have question number 1, right? Okay. The initial concentration of a reactant in a zero-order reaction is 0.75 m. The rate constant K is equals to 0.015 molar per minute. What will be the concentration of the reactant after 15 minutes? And how long will it take the concentration to be reduced to 0.6 molar? Okay, so our first required concentration of the reactant after 15 minutes. So this will be final concentration because it's after 15 minutes. And then how long will it take the concentration to be 0.006 molar. So meaning the time it takes for the initial concentration to be reduced to 0.006 molar. Okay. Okay, I don't have to rewrite in a pentagon because it will take time for me. I have only small time today to discuss a little bit. Okay, so this is not method of initial rates because there's no experiments or there's no experimental data, okay, to be used in our solution. This is integrated rate law. Okay, so and this is all about zero order reaction. So for the zero order reaction, the integrated law will be, the formula will be, or you see the formula? Okay, we're using the formula concentration final of the reactant A. But first we need to have the reaction first. A to B. So this is our reaction only, okay? For this problem. So we have to use the equation, okay? Concentration of A, like that, is equals to negative K times T plus the initial concentration. So this will be the formula to be used. This is integrated rate law of chemical reaction or chemical kinetics for the zero order reaction. For the N is equals to 0. First order, no, zero order, sorry, zero order. It's mentioned in the problem, right? So what will be the concentration of the reactant after 15 minutes? So this is final concentration after 15 minutes. Okay, so at 15 minutes, we have concentration, which is unknown. This one. Final concentration will be unknown after 15 minutes. So substitute the value. Okay, EF is equals to, okay, negative K. Our K, our rate equation constant, our rate constant K is mentioned in the problem, which is K is, okay, 0.015 molar per minute. This is our K mentioned, okay, like that. So take note, the time is expressed in minutes, okay, like that. So it would be better to express this in seconds first as our standard unit for the molar or molarity for any order rate of chemical reactions in chemical kinetics. Convert this to seconds, okay? First. Okay, so we have K times T plus A, but it's up to you if you will convert or not. As long as, you know, there will be a parallelism, or there will be a uniform unit used, and it will be cancelled somewhere along in the solution, somewhere along the way in your solution, no problem. Okay, if you will convert it or not, as long as it will agree the units. Okay, like that. But since molarity is in terms of seconds for the zero order, then it's better to convert. Okay, like that. So A, but here we need, because the time is 15 minutes and the K also is in minutes, so we will first have the idea that we will not convert this first. Okay, actually it's up to you. Okay, substitute na tayo ha. 15 minutes. Okay. This one. Plug in the given in the problem. Okay, so we need to obtain a final concentration after 15 minutes, which is equal to, I get my calculator first. Okay. Convert or not, it depends on you, huh? If the units will agree. Okay, so when 0.15 plus 0.75 when 0.5 times 15 plus 0.75, that is negative, so 0.015 times 15 minus 0.75, so negative 0.525. Okay, the negative here represents because we have a negative K here. Okay, so our final concentration will be 0.525. So 0.525 molar. So this is our answer in letter A. In the question, what will be the concentration of the reactant after 15 minutes? So the concentration of the reactant after 15 minutes is 0.525, in which originally this is 0.75, the initial concentration for this. So from 0.75 to 0.525, so it's reduced. That's why it is 0.525. This one, meaning this is reduced. No need to put negative. This means it's reduced to 0.525 from 0.75. This is our initial concentration AO. Okay, so that's first, what will be the concentration after 15 minutes? Second, how will it take the concentration to be reduced? Okay, so in letter B, this is letter A. In letter B, time. We use the same equation, this one, but we need to compute the time for letter B. Here, use the same equation and compute for the time and substitute the values, since we have reduced to 0.06 molar. So our final concentration will be 0.06, but use that time given, which is our unknown pala. So time will be computed. Okay? So but use 0.06 final concentration of 0.06 molar as our AF already. Okay? So use this one. So TK is equals to AF final over, okay, so let's do this as, okay, negative K plus AO equals to AF, then negative KT is equals to AF minus AO, negative K is equals to AF minus AO over T. So this will be our formula for K. We derive from this equation and solve for the value of, K. Okay, like that. So, K. But we need to solve the T, okay, not the K. How long will it take the concentration to be reduced to 0.06 meter? Because we have already the K. Okay, so T siya. Sorry, T. So it's just the same. Okay, so T is equals to AF minus AO divided by K. Okay, so ito pala siya. T kay time man atong gipangita. So time, we need to find the value of T. So final concentration of A minus initial concentration of A divided by negative K. So substitute values. Okay, time. So our final concentration is 0.06 molar. This is final. Okay, molar minus our initial, which is again 0.75. This one. Our initial concentration is 0.75. So subtract that here. Okay. 0.06 minus 0.75. Okay. Still molar. And then divided by the value of K, which is equal to 0.015. Okay. So we have the time already. Okay, like that. Okay. So our time will be 0.06 minus 0.75 negative like that. So 0.06 minus 0.75, the answer will be negative from the numerator and negative also for to the denominator, and we can obtain a positive time. Okay, so 0.69 divided by 0.015, so 46 minutes. Okay, so we have 46 minutes, the time it takes for the concentration to be reduced to 0.06 molar. Okay, letter A. Okay, we have the answer of 0.55 molar. After 15 minutes, the final concentration is 0.525 molar. Then, the time it takes for the concentration to reduce to 0.06 molar will be 46 minutes. Okay, this is question number 2. Okay, finish na ta. So, 2 problems finished already. Okay, so that would be enough, and we will go to the problem number 3 later. Okay, this is, thank you so much if you learn a little bit for this integral rate law. This is integral rate law. This is not the uh, method of initial rates or the shall we say the natural rate law without involving the integration. The integration here meaning we come up for the formula based on the integration, but I don't have to derive that because it's been there already. And all we have to do is to memorize the zero order reaction, first order reaction, like that, okay? So that we can use that in this type of problem. The only difference is that in this problem is that there's no experimental data. Experiment 1, experiment 2, experiment 3, experiment 4. Now, there is a series of initial concentration and this is a series of initial rate. So in that way, you can use the other equation. But here, it's automatic. And then it's not mentioned also the specific chemicals that involves for the, for the reaction process. It's A and B like that only hypothetical. We don't know in this problem what are the chemicals are uh, involving the chemical reactions, okay, like that. So thank you so much for listening for the live stream and for watching this video. If you did not subscribe yet my channel, then you can subscribe now and then click the notification bell for some newest updates of I Am a Singer Channel Voice. Okay, bye bye, God bless everybody.